Hello, everyone. Welcome to the Casual Causal Talk, episode 10. Today, we have with us a very interesting personality, an active sergeant. Thomas Bilach is an active sergeant in the New York City Police Department, and he is also a lead scholar at the USA Justice Department. Thomas, welcome to the show. How are you doing today?
I'm doing wonderful. Thank you for having me, Venkat.
Thomas, thanks for joining me. And the very first question that I have for you is, how did an active sergeant get interested in causality?
All right. Well, it depends on how long we have, but it's a long journey. So again, starting my career just as a police officer, young police officer, 21 years of age. To make a very long story short, working in a lot of different jurisdictions, working in neighborhoods like Bedford-Stuyvesant, Brooklyn, Brownsville, Brooklyn, working foot patrol, motorized patrol, being involved in a lot of initiatives that the department was in. It was part of it was just a journey, just to discover myself. And a lot of times when I was coming up, through the department and we would participate in a lot of these initiatives, oftentimes we were told, hey, look, this is what we're doing. This is an initiative that the department sponsors. We believe in this and we believe it works. We would hear that a lot. This thing that we're doing is effective and it works. But when you're young, when you're a young police officer, you're kind of told what to believe. And I don't know, like if you're familiar with, the stop and frisk program in New York City, or at least a little bit about it. There was a, major court case about that. I became a little bit disenchanted with that program because it just started to, we started to increase, the frequency, the intensity of the program. And again, we were told that going out there, stopping individuals, this sort of thing works. This lowers crime. This reduces shootings. And again, you're told a lot of what to believe. So a lot of the journey just started with trying to discover myself. The department actually paid for my graduate education. So I got a degree in criminal justice from the University at Albany. And when I was there, the professors there really taught me how to think. And then after finishing that degree, coming back, I did some work in operations research, policy writing, at the, working in, the Office of Management Analysis and Planning. And that was a unique experience, but the people I was surrounded with in the organization, when I started to do more operations research, there were a lot of people with their MBAs. There were a lot of people that were journalists. There were a lot of lawyers, and there were very few data scientists that had that sort of quantitative expertise. So I actually pursued another degree in quantitative methods in the social sciences at Columbia University. And that really helped take things to the next level because again, it's a long story, but of my journey, but I was able in that training or in that my schooling to really, if I had these questions, hey, we did something in this geographic area. Did it work? They taught me and gave me the skill set to be able to answer those questions and not just be told what to believe. So that was really my journey. My journey was just having these questions. We're doing something over here. It works. It's effective. And oftentimes we would say that, but we rarely would ever test these things in reality. So that's sort of what I wanted to do. I wanted to be able to answer these very difficult questions about what we were doing as police officers. And I didn't think, I really wanted to get that skill set for myself and do it in my own.
Oh, pretty impressive. It's very rare that, a sergeant is also an active data scientist. I haven't come across many. Perhaps you're the first one whom I'm interacting with, who is also an active data scientist. And it's really remarkable that, at your job, you want to do the right thing, but through, data science. Moving on to the next question. What is causality according to you? This question is actually inspired from The Wired, where they ask, to explain a particular topic in 5 levels of difficulty. But for the want of time, I'm going to cut it short to 3 levels of difficulty. How would you explain causality to, a grandma, easiest level, and then a college fresher, and the third is the toughest level, a fellow causal expert? You can take an example from law enforcement, or policing, if
Yeah.
you like.
Nothing like the difficult questions early. I love them. No, this is um I think in that Wired, right? They did algorithms at 5 levels,
Yes.
I believe, right? And 3 levels, it's difficult. So for explaining it to a family member like my grandmother, again, so like causality. If I were to break it down to the simplest way, so we have X causes Y, and trying to break this down, obviously X should precede your outcome, and not just that they're occurring
Hmm.
together.
Hmm.
So imagine I'm taking 30 police officers and I'm putting them at a fixed geographic area, fixed location. And maybe we're looking to see if crime goes down in that particular week. But there's a lot
Hmm.
of other things that could have been going on in that particular geography. It could have been a holiday week, right? It could have been July 4th and everyone's leaving New York City. So there's less people outside. There could have been heavy rain that week. So there could be other explanations for, let's say, why crime might have declined in an area where there's just this surplus patrol strength.
Hmm.
And so that's just explaining that, X causes Y and that they don't necessarily occur together and that X precedes Y. I mean, that would be the simplest explanation. I don't think I need to explain to my grandmother, she's a very wise woman, that correlation doesn't always equal causation. She probably knows that already. But that's just at the very basic level. When we, you know, I mean, I don't work in academia, but I have worked with, students before who have, so like a college freshman. This is where I would start to introduce this idea of paths not taken or alternative explanations.
Hmm.
So, in like a law enforcement perspective, we're looking to, let's say, deploy resources to, again, a geography. Think of something like Times Square, and we're looking to do quality of life enforcement in that area.
Hmm.
And then we're going to follow up after we deploy them for, let's say, 3 weeks and see if violent crime goes down in that particular area. But I'd expect the college freshman to know that, well, okay, what if we looked at the other areas around Times Square and if crime were to go down in the treated areas and it went down in other parts of the city as well, is that due to the fact that there was more officers there? I'd expect now the college freshman to start thinking about, well, what about if we compare Times Square to another area like Herald Square, you know, heavy foot traffic, vehicular traffic, major shopping center. Let's compare it to an area where we did nothing and
Hmm.
then see if crime decreased in that area as well. Again, I would expect that at the college freshman level, when we're thinking about causality, right? We're trying to separate now with the signal from that noise
Hmm.
and using an alternative, using a control group and trying to rule out those alternative explanations by using a suitable comparison group. That would
Hmm.
be, I would say, the college freshman. The causal expert, I mean, we could probably talk for hours, but it's trying to tease out causal effects, working with a set of assumptions, trying to estimate counterfactual outcomes. So we think about a foot patrol initiative having a reduction in violent crime.
Hmm.
Well, the causal expert and I, we're going to have a long discussion about, well, X causes Y, but sometimes Y feeds back into X. And our outcome, might start driving the actual selection process. We see this a lot in policing, where we're deploying to areas that already have this like demonstrable need. They need this particular treatment. So that's where we're going to send our additional resources. That's very problematic, right? With selection bias. Um, Simultaneity concerns, right? And so this is what the causal expert and I are going to discuss. And we're going to employ probably quasi-experimental methods, difference in differences, event studies, matching, some combination of those three. We're going to look for parallel trends between the treated areas and all the other areas that we're not going to treat or send
Hmm.
these additional cops to. So again, the causal expert, it's about assumptions. Are those assumptions reasonable? And yeah, we're
Yeah,
going to have a
we have
long
a
discussion about
yeah, we
this.
have a game coming up on the reasonableness of the assumptions. Down the segment, we'll definitely talk about it. I think you
Mhm.
also alluded to the point of confounders, right?
Yeah.
Is that also a concern normally when you're trying to, do causal inference?
In policing, it's always a concern.
Hmm.
Again, this is what quasi-experimental methods in general are just what we, just what I was always drawn to. And it's not as if I wanted that. It's because, and as we could talk about it as well, randomized controlled trials, right? The gold standard. We don't see that often in policing. You'd have to have careful control over all of the different facets of the research design, where you're going to deploy. And it just doesn't necessarily work like that, because in policing, right, we're also nested in this political institution, right? So we're going to direct resources to where they're needed the most.
Mhm.
And so that's a problem for causal inference, is that sometimes our outcomes themselves drive where we go.
Mhm. That was going to be my next question. I mean, there are two ways to establish causality, generally speaking. It's the RCTs, and then you have the quasi-causal methods. In your field and economics, and in my field of marketing, we have historically used only quasi-causal methods because RCTs are simply not, amenable to do, right? There are so many difficulties to do RCTs. What are the typical challenges in administering an RCT in policing?
So in policing, yeah, there's ethical concerns. One of the ethical concerns, there's political concerns. Again, I use this example. I mean, just recently, trying to increase certain jurisdiction. There's an influx of officers, newer officers coming to an area, and they're going to be sent to this area to serve some sort of patrol initiative. But I mean, recently, at least in the area that I worked, some of the residents had a concern because they weren't part of the treated group. They
Mhm.
actually knew about the initiative and were upset that, hey, I don't know why these areas are receiving the additional or the surplus patrol strength. Why aren't
Okay.
we receiving them? So then
Mhm.
there's these concerns, right? So if we start to randomize treatment, we're going to end up sending officers to where they're not needed the most. And then there's going to be those concerns that residents might have. Well, I think we deserve these additional resources as well. That's one of the major impediments that we see with randomized controlled trials. It's a needs based environment,
Mhm.
and we're going to direct resources to where they're needed the most.
Mhm.
So ethical
I,
concerns are probably at the top of the hierarchy when it comes to RCTs.
mhm. I mean, extending that particular argument, I'm not sure whether a concept such as curfew happens in New York, but in this part of the world, a curfew is something like a lockdown, where
Yeah.
because of social order breakdown, the police department decides that, hey, nobody comes out of the house from this time to this time, and this particular county, has this particular lockdown, but the other county does not experience it. And the county that is experiencing a lockdown would say that that's not fair on us. We didn't do anything, but why are we, subjected to this? Do you think that's also, a kind of like a ethical concern here?
I think it's a very ethical concern. I mean, just to quick follow up. So it was the lockdown an experiment, or is that someone that's experimented all over you know,
Yeah.
all over the particular area where you live?
No, no, it wasn't an experiment. I
Oh,
mean, there are certain times where the social order kind of breaks down due to a lot of things, like, for example, demonstrations going out of hand
yeah.
and something like that. And police want to maintain law and order, so they would just tell that, hey, this particular area we are going to administer a lockdown, and the other area is not going to have anything of it because they are normal.
Yeah.
But then the
Well,
population in that particular county is going to suffer for set amount of time.
yeah, that's definitely going to be a concern. We saw that a little bit with here in New York when there was a lot of protests in early 2022.
Okay.
Um, you know, closing down parks early, curfew. We don't really experiment, don't really have a curfew here in New York, or at
Mhm.
least we can't stop and detain someone for being out late just on
Mhm.
that basis alone. But that is definitely a concern. And of course, experimentation itself. I mean, I have some research looking into this that, I mean,
Mhm.
most, I mean, some academics would assume that the experiments that we do in certain communities, that there's these unidirectional effects that, hey, look, we're doing something. It's in other words, that there are, you know, we can't, by unidirectional effects, I'm essentially saying that we're doing something in a community,
Mhm.
and it's automatically assumed to have, a positive effects. It's assumed to, there could be no harm. But as we see with some interventions, that's not always the case. It's not always the case that there can be backfire effects when you do an intervention such as that, where you actually make things worse. So that's another concern. I've had academics tell me that, well, we're doing something, there's this social good to it. There can't be any backfire effect, but that's actually not the case. If you experiment in a jurisdiction, there can be this backfire effect that can make things worse, actually.
I had a look at your profile, and you have a very impressive cross-validated profile. Typically, data scientists have a good profile, but an active sergeant also having a good, active profile on cross-validated is rare. And you come across as a person who knows, the in-depth of all the statistics. How much do you regard the concept of statistics to be of use in causal inference? Say the concepts of p-value, confidence intervals, etc.
Yeah, it's I'm going to be quite blunt. I mean, in policing, we don't use them that often. As a crime analyst, we're often looking at we're looking at counts of crime over time, or we're comparing them across jurisdictions, and we might do a simple a difference across time, and we might be looking at these differences across time. But the most important would be a confidence interval to talk about how much uncertainty is in your particular estimate. Especially some of the research that I've done, we might see relatively small effects if we do an intervention compared to areas we didn't treat. In policing, we might focus on something like a crime rate, like the number of crimes per 100,000 residents. And, if we see a reduction of, say, 2 crimes per 100,000 residents, right, after we did this really large scale initiative, I mean, there might be uncertainty around that estimate, but is also that estimate, what's sort of the practical importance of that as well? So confidence intervals, p-values, to be quite blunt, as a working in crime analysis, we don't use them, I would say, as often as we should. But a confidence interval to talk about how much uncertainty there is in this process is probably the most important.
What about the workhorse of quasi-causal experiments, the linear regression? Do you think every causal analyst out there should know the in-depths of linear regression?
You should. I mean, it's the workhorse method. Economists, when they look at the matrix algebra, x prime x inverse x prime y, everything's really just a twist on that.
Yeah.
So, linear regression, it's that workhorse method. You should know it in and out. Typically, it's a place where you start. It's not going to be really the place where you end. But typically in policing research, again, it's again, sometimes the place where we do end, but you really, you have to know the ins and outs of linear regression, if you're going to advance, especially in a field like policing.
Let's talk more about your line of work. I came across this excellent article of yours on LinkedIn talking about CompStat. What exactly is CompStat to begin with?
CompStat. Well, so CompStat is an accountability mechanism. And it was implemented in in 1994, beginning 1994 into 1995. And CompStat is short for, there's some argument around this, but compare statistics. Some people say it's computer statistics, but it's really compare statistics, because what it is, it's comparing crime in a particular time period in a specific jurisdiction to the previous year. So CompStat sort of evolved just kind of naturally, because in policing in the mid to late 90s, there was a substantial delay in the data that the police department actually had. So they would hold meetings with commanders, and many commanders didn't even know how many shootings or how many homicides they had in their jurisdiction. If they did, there was often a 3 to 6 month lag. So they really needed to sort of improve their information systems. And a lot of it with CompStat was retrofitting these private sector tools into policing. So CompStat, by accountability mechanism, was first we needed a more sophisticated system, right, to get our crime data, to get them out to the precinct commanders, and then we also need to hold them accountable. And then they're typically held accountable at these CompStat meetings, where commanders from a specific jurisdiction are called to they're called to a meeting at a centralized location,
Mhm.
and they're asked to defend what's going on in their jurisdictions. So if they are doing an initiative, or they're experimenting with some specific type of patrol deployment, they're going to be asked to defend that in front of the kind of the upper echelon of the department, the executive leadership. And it's a way of holding them accountable for the plans that they put forth and things like that. So again, CompStat it's accountability tool. It's been credited with an 80% reduction in violent crime from its heyday in the mid 90s all the way to, today. That's a substantial, it's taking a lot of credit for the crime, the crime decline in New York City. And so some of my research has sort of looked into that a little bit deeper. Exactly. This accountability tool, is it really moving the needle on crime? Is holding commanders accountable at these meetings? And we can go a little bit deeper into what these meetings actually are.
Mhm.
Is that really making them more effective leaders?
Mhm. In your article, you also caution people that, hey, do not compare year-on-year comparisons. That doesn't lead to much. Why do you say so?
So CompStat, so every commander is given a CompStat sheet. I like to call it a CompStat report card, and they pay attention on this CompStat report to 7 major crimes. There's 7 particular crimes that are of importance. They're usually reported up the chain, right, to the FBI. And that's where that's where our official crime statistics are, are, put forth to the public, right? But they're collecting from all agencies throughout the country. But the CompStat report that the commander gets typically is a comparison of that unit with the prior year. That's it. There's really you're looking at yourself, and your counterfactual is essentially in the past. So, there are problems with that, but it's a comparison of counts of crime in a jurisdiction to the previous year. And then they report percentage changes. There's problems with that as well. And one of the things I gave a talk in Arizona, Tucson, Arizona, about CompStat, and we were going through some simulations with, how there could be a bias with percentage change. And so imagine, and I wanted to do this live, but it's a little bit difficult when you're at a conference doing a presentation to do this live. But well, let's just say I had, wanted to create some fake data for 2024, like simulate data from a Poisson distribution. We can allow for some dispersion. And then we want to simulate data again for 2025, again, simulate from a Poisson distribution. And we can ensure that the means of the two groups are the same. So what I did is I said, well, let's just do that. We'll do this thousands and thousands of times, and we'll calculate the percentage change, and we'll look at the distribution of the percentage change, right? The percentage as a distribution. And, percentage change, it's not symmetrical. So a simple example would be, let's say you have 10 crimes in a jurisdiction, and you then 10 homicides. And then in 2024, and then in 2025, you have 5 homicides. Well, homicides halved, right? But if you switch that and you have 5 homicides, and then you increase to 10 homicides, and you look at the percentage change, right? Look at that. That's a complete, it's 100%, right? So it, in one sense, think about what sounds better. We have a 50% reduction in robberies or homicides, or as opposed to we have 100% increase in homicides. So there's not that symmetry. So you can have the same absolute change, but the relative changes are quite different. So of course, there's that little bit of bias in that. Well, so when we did this, when we calculated this percentage change, and we did this tens of thousands of times, it wasn't uncommon to see very large percentage changes just by random chance alone. So in a random system, if you were comparing crime in the previous year to today, just by random chance alone, with these small numbers of 10 and 12, it's not uncommon for a commander to see a 120% increase in offense counts for relatively small numbers. So the CompStat sheet will highlight that number in yellow. You're more likely to see the bigger number. And then there's this action bias. You feel like you have to do something because you see that big percentage increase. But in some of my research, it was shown that you can a lot of those percentage increases you would see by random fluctuations in the data alone. So crime is a very noisy measure if you look at it year over year, and that could be problematic because then when you're called to these CompStat meetings, you'll often have to talk about those percentage changes and then tell the leadership what you're doing about it. But I can tell you right now, there's going to be no leader that's going to say, well, it's just an 80% increase. It's not that big anyway. And I think everything's fine. You just, everyone feels that need to talk like they have to do something.
Mm-hmm.
Did I break that down for you? Like the issues?
Yeah, that was excellent. Yeah. I think my follow-up question would be that you continue to argue that a good remedy to this particular problem is to have a good counterfactual where you have a unit that is unit in the sense that a county or precinct that is not treated which compared to a county or precinct which is treated. Can you please elaborate more on this?
Yeah, and that was that's where we took it on a whole nother level because a lot of the purveyors of the CompStat method still to this day believe that cross area comparisons are completely invalid. Mm-hmm. That is not I mean in a city like New York City, right? If you're going to experiment in a few jurisdictions, right? There's 77 patrol jurisdictions. Mm-hmm. So if you're going to experiment in a few of them, you have a large number of jurisdictions where you can estimate a counterfactual. All right? Mm-hmm. Counterfactual, just counter to the fact we did something in these areas. What would have happened if we just done nothing? So it's it's very rare that in a CompStat meeting, you will hear commanders do that sort of basic analysis where there's something we did in our jurisdiction. There's these areas over here that look like us, have a similar problem. They didn't do anything. And we saw crime, decline even further in our jurisdiction than those. So the counterfactuals are very important in policing. They're not used as often as we'd like, as often as I'd like. And there's even other examples where we've seen, like in New York, there was recently, the police department was called to the city council to talk about their gang database. And some people have issues with the database. I mean, it's very easy to get in, but it's difficult to get off of the gang database. And the police department, for very good reason, uses this to, track violent offenders and to figure out where they need to deploy. But one of the questions that was asked by the city council members was, well, how effective is the gang database? And the questions were all directed towards the deputy commissioner of legal matters, an attorney. And that question of effectiveness, it kind of just, I really think they could have pressed us a little harder on that, because think about this. If we're using the gang database in a particular area and it was successful, we talk about it, but we don't talk about the areas where we don't use it. And so that particular response was, well, we can't prove how effective it is because we can't prove a negative. And again, it's just, that's because some of our leadership, they don't have that sort of counterfactual thinking. We're experimenting, right? So we're deploying based on the information in the gang database to these areas, but there's other areas we're not deploying to. So if we're only talking about the areas where we're doing something, of course, it's going to seem like everything, the gang database is a huge success. So I'm not here to really discuss how effective it is. I'm just saying that was a really good question that I think the council members could have, pressed us on. But to just say that we can't prove a negative, well, that's what estimating counterfactual outcomes is all about.
Yeah. The cross-unit comparison is definitely a step up in comparison to year-on-year comparison. But in my field of marketing, clients really go crazy when I tell them that, hey, you got to go dark on a particular market and where you don't have to, do anything. And they would be like, hey, I'm going to lose 400 or 500K worth of revenue per week if I go dark on a particular market. So a market is acting like a sacrificial lamb. In the policing domain, wouldn't a particular community or precinct come to you and say that, hey, why is no patrolling being done for us? I get that we are a control group, but what if some crime happens during that interim period? So how do you allay those concerns in that case?
That's a really good question. Crime can change. Crime can move relatively fast. You have to respond to crime very quickly. Mm-hmm. So if you're doing an intervention, I'm not an advocate of a sustained sort of approach. Mm-hmm. So for instance, like we also do experiment a lot with zone deployments in New York City. So we might have officers on overtime experimenting within a particular zone, but if crime moves, or we can get feedback from residents saying that, hey, we have this crime problem here, well, we should be able to move our zones. And that's where causal inference, again, gets very, very challenging. And one where I'm really, I love to talk about, because, right, as we start to move, treatment is not always permanent, right? We might have to move our particular zone. So some of those smaller street segments and block groups within those zones are treated, but then as we move them, they now switch out of treatment, and another group of becomes treated. So now we're in a totally different ball game, where you could be treated in one period, untreated in another period, then you could be treated again. So I believe crime, you do have to move rather quickly to address crime, because crime is extremely concentrated, and it's a small group of prolific offenders that commit most of the crime. Mm-hmm. And so we develop patterns, and it's important that we try to close those patterns very quickly. So, to allay those concerns, I mean, if you were getting feedback from community residents, I would expect that we would be able to adjust and move those zones accordingly. Mm-hmm. You have to be very adaptable in a policing environment.
Yeah. In our marketing field, as a compromise, the client suggests to us that, you conduct these experiments when we have a lean period of sales, where not much of sales happens, so that, we can mitigate our losses. I'm pretty sure there is no lean period as such in policing, right? You can never predict the crime surges or anything like that. Or is there some kind of a lean period from your experience?
Prediction. Now I'm well in the world of causal inference, and I would say causal inference, the way I would describe it, you could almost think of it, it grounds the prediction into actual evidence, if that makes particular sense. But there is some work being done in predictive, I guess you could say predictive policing. I'm a little bit skeptical of it. Interestingly, that some of the work that's being done in it, there was, like in New York, one popular method is so for instance, if you have a homicide in a particular area, one particular style is well, if you take a crime in an area, we then tend to flood that area with resources. And we might want to put officers on foot. We might want to put foot patrols in that area, bike patrols in that area. There might be a 96-hour plan in that area. But some of the research I've done has suggested, well, if we pulled all of those, all of the homicide data, right, and we looked at, well, where is the next event likely to occur? Well, it's probably not going to be in the same area where you just took a shooting, right? So your best bet is to deploy to an area other than where you had your shooting or your homicide, which again is it just contradicts the thinking of most of our precinct executives. You take a particular crime in a particular area, and you tend to then adjust to that area. You might want to put officers in that area for a fixed period of time around the clock, but all of the data would suggest that your next event is going to be in a place other than where you just took your homicide. Again, that's a little bit difficult for a lot of the leaders I work with to understand that and this is just taking historical data over the past 20 years. Your next event is not going to be at the same location. It's highly unlikely it'll be at the same location.
Yeah, we touched upon prediction a little bit, predictive accuracy. I believe that, once you establish causality, you make that particular event more deterministic as opposed to being probabilistic, right? For example, in my case, I can say that, hey, if I increase some spends on Meta, my sales is going to go up. It's a very simplistic example. I know it doesn't hold true for policing, but do you think in general, if we have established causality, we move from a predictive realm to a more deterministic realm?
We do. Like I describe causality as just, pulling, again, it's just pulling levers, right? We're going to increase, the number of officers in this, this particular fixed geography, and we're going to monitor crime, going forward. So it's about pulling levers. And there's a lot of experimentation going on in New York City that goes unevaluated, in my humble opinion. There's a lot of experimentation at a very local level that we just don't harness enough of it. I mean, just kind of what makes it into an academic publication is a very, very, very small window into what we're actually seeing. So we're not really harnessing a lot of the knowledge that we could be getting, from the field, because precinct commanders at a local level are experimenting with deployments on a weekly, sometimes monthly basis. And as crime analysts, we're just so busy and inundated with work. It's very rare that we get to evaluate and see exactly what we can really influence. So again, prediction is a little forecasting, a little bit outside of my wheelhouse. Not very good at prediction, at least I don't think. But predicting crime beyond after a certain number of period, your error bars just get too wide, and I just feel it's a little outside of my wheelhouse.
Talking about predicting crimes, in popular culture, there was this movie Minority Report. I think it came about 20 years ago, where police department could prevent a crime from taking place. They could envision the crime taking place and hence prevent it. Do you think causal inference can give those superpowers to any police department to envision a crime taking place and thereby prevent it beforehand?
That's a really good question. I'm trying to think if I could. I mean, causal inference. It doesn't give us, it doesn't give us these sci-fi, superpowers. I don't think, and they don't let us. We can't really always stop crimes before they happen, but we can have a little bit more. We can have a little bit more humility in policing, and we could discuss things. We could just discuss strategies that actually work, and we can discuss ones that are just more window dressing. So, yeah, in my opinion, that's more valuable than just these real futuristic fantasies. But we could be more honest. Yeah.
But do you think we can address the symptoms in the movie Minority Report? If I recollect correctly, they prevent a crime from taking place, and then they say that this particular person was antagonized due to some of his family issues and something like that, and because of which he wanted to take that anger out on somebody else. So if we can address the symptoms, perhaps we can prevent the event from taking place. Do you think causal inference at least can help in that regard?
Yes, and that's why I always said, and I don't know if someone coined that term, but it's going to take that. It's going to ground a lot of our prediction. It's going to into actual evidence. But addressing, the symptoms, I would have to agree with that claim. I'm not sure if I could expound upon it, but I do agree with that claim. Yeah.
Okay. Moving on to the area of expertise of yours, difference in differences. I have seen a lot of really excellent answers on cross-validated from you. DID, I would think that it's kind of like a hello world of programming, but for the causal world, right? Why do you think DID, is so popular?
Difference in differences. Why is it so popular? I mean, at a very basic level, it's very. I want to say it's simple. I mean, it is, right? Because we're looking at a treated area before and after. We're looking at a control area before and after, right? So we're assessing crime, both we're assessing outcomes across time and across space. It's very popular. Probably one of the most widely used, I think it is the most widely used methodologies in the social sciences today. I just think it's very intuitive to compare a treated unit before and after to a control unit before and after. It's, assessing parallel trends is not so easy. We could take that apart a little bit, but that's part of the reason I just think it's just it's an intuitive methodology. And that's why it's so popular today. And it also allows us to control for a lot of things, but we could break that down a little further if you'd like.
Yeah, I think much like linear regression, yes, it is deceptively simple, but it's also, a lot difficult to get right if you just, look at the under the hood mechanisms, right? DID is not that simple. It's deceptively simple, though. And talking about
it's
parallel,
deceptively simple, right? That's actually a better way to put it.
Yeah. And you talked about parallel trends, right? Have you seen from your experience that, two counties or two precincts are having not exact parallel trends, but somewhat similar?
Parallel trends are not always parallel in policing, right? Partly because we have that needs-based policing that we're doing. So, and of course, because we're experimenting, right, in areas that are already having that need, they might already be experiencing elevated rates of crime. So of course, the levels of crime are going to be different, right? So the treated areas are going to have a higher level. And there's always going to be some divergence. I just think in a paper, you have to be very honest about that divergence in parallel trends. And if there is a bias, well, maybe we can try to quantify the direction of the bias. And typically what I'm seeing, most of my applications, those treated areas compared to all of the other ones that weren't treated tend to be seeing a little bit of a slightly upward trajectory. And we typically often experiment in warmer climate, the summer months. And so those areas are going to sort of revert, are going to sort of experience some regression to the mean. And we don't want to mistake that for an actual treatment effect. So we do want to quantify the direction of that bias. Do parallel trends always hold? No. I mean, especially if we break down a precinct into smaller geographies, like if we're looking at sectors or zones or census tracts within a precinct. So you just have a massive data set and you're looking at, let's say, 9,000 census tracts over 20 years, and you're looking at the parallel trend system, you're almost certain to fail those tests where you include like a placebo treatment, where you're trying to say, hey, here's a fake treatment, right? Where it's going to assume the treatment started 1 week earlier, 2, 3. You're almost certain to fail those tests because you have so much data. So I think it's very important that we be honest about parallel trends. In the real world, though, I don't think it always holds. And I also don't think I think we should treat it as like a statistical problem we need to overcome. But often that's the case. Just be very honest about it. Show your trends and report the findings, and just be very honest.
Yeah, don't let perfection be the enemy of good, right? I mean, if you were to go by the academic rigor, you will never have a DID application in real life.
No, you would never. So honesty is the key. Show your trends. Be very honest about them. Quantify if there is a divergence, try to quantify that. Just be very honest about how things are going to, if you're assuming that that's some reality about how things are going to proceed into your treatment phase, again, as the researcher, you're going to have to defend that these trends would have persisted if we had done nothing. That's often very difficult to defend, but that's the job as the researcher to do that.
We have talked about the vanilla DID, right? Of course, there are more complex forms of DID. In my field of marketing, a client came up to us this year and said that, hey, we are going to roll out campaign in New York. We're going to roll out campaign in Texas, but not immediately. We don't have budget for it. We will roll out the campaign in New York in March, but for Texas, we will do it in July. This kind of staggered, arrangement calls for a different application of DID, which we call as staggered DID, right? Have you applied staggered DID in your domain of policing? I'm assuming that it will be quite the norm because the resource constraint is also there in policing, right?
So have I? Yes, I have. So if we talk, we'll talk a little bit about, well, has it been done in a policing context? So in 2015 or 2014 into 2015, the police department experimented with a completely new neighborhood policing, philosophy. It was known as the Neighborhood Coordination Officer Program. It was just a different way of doing community policing. It was freeing up officers, giving them downtime from the radio, the not answering 911 calls, interacting with the community, holding, I guess you could say, smaller block level, I guess you could say almost like, meetings with community residents at a more local level. And essentially those officers were responsible for the crime and disorder within their specific geography. And that was rolled out. Essentially, officers would receive a new influx of personnel because the police department is very big. And so they have officers in administrative and support units. And so they can take officers from one area and they can use hundreds of them and use them to fulfill these types of initiatives. And so that most of our initiatives are rolled out in waves. So they might say, hey, in this particular part of Brooklyn, the northern part, they're going to receive the treatment first. And part of it is just resource constraints. I mean, I just think in a city like New York, you can't just roll out a citywide initiative just like that, And of course, there's personnel issues. So we often roll things out in waves. This part of Brooklyn will get this part of the treatment, this part of Manhattan. Then we work our way to the Bronx. And then eventually everyone becomes treated. That was an example of a staggered difference and differences approach. I don't think they used difference and differences, though. But they did, evaluate a treatment that was implemented in a staggered way. My own research, where we looked at summer all-out deployments, and essentially that was a similar sort of philosophy where we're taking officers who work in administrative positions, officers that work in, they work in the training bureau, they might work in all of these administrative and support units. We take hundreds of them and we deploy them into areas or into precincts to serve a basic foot patrol function, maybe like a sentinel-based foot patrol function. They're there for presence, and they're there, again, in my interviews with officers, they're there to deter violent crime, to stop violent crime from occurring. But they're only sent to a small subset of precincts, maybe 8 to 10 of them per year. And then they're remain in that jurisdiction for approximately 3 months or 90 days, and then they're pulled back. So in my own research, I've kind of looked at this over a decade-long period of this switching on and off of treatment. There's an influx of officers to a set number of jurisdictions, a small subset of jurisdictions, and then for a 90-day period, and then they're pulled back. So it's this switching on and off of treatment. But the complicated part about it, it's not the same precincts that are always treated every year. So in 2014, you might have 10 precincts that are treated. In 2015, you might have, well, some of them are the same, but then some drop out. And now you have a new group of jurisdictions that are exposed. So again, that's not entirely a staggered treatment, but that is a switching back and forth of treatment that I had to evaluate. And it was very difficult to, from thinking just in causal inference to overcome that because, well, is receiving treatment in a prior year, does that make you more or less likely to receive treatment in the next year? How does receiving a treatment in a prior year affect parallel trends in your second wave of treatment? There's all these other considerations you have to make. I think in a field like criminology, we haven't been very honest about the variation of our treatment variable over time. And I think really like in 2025, moving into 2026, with this explosion of new tech, new software that's out there, we have to be very honest about the comparisons we're making. Because I think in prior studies, most researchers would focus on the first of many successive treatments. So if there was a switching on and off of treatment, they might just focus on the first. It's hard to really say that because their study didn't sort of look at the full sort of treatment variation plot and how treatment was sort of distributed over time. So in short, most of what we see in policing, just because of resource constraints and personnel deployment, is staggered because we need to roll it out throughout the city. But then there's also policies are not always permanent. There is this switching back and forth. So you might have a staggered exposure, and then eventually later, years later, a precinct then switches out of treatment. So there might be staggered entry and then staggered exit. So I actually think that was a question that I probably asked you on LinkedIn about that your particular package. Yeah, because can you account for that reversal of treatment? So yeah, that was a little bit long-winded, but I hope staggered exposures are very common, mainly due to resource constraints and budget.
Yeah, I mean, interestingly, our product is called Detective. A pun on the word detective. It's DID instead of DET. And of course, we are going to roll out the staggered effect, feature very soon, because that's how, generally people operate. We just can't assume that people will roll out all the campaigns at the same time. There are a lot of resource constraints, as you talked about. Just last week or a couple of weeks ago, I also interviewed Dr. Nick Huntington-Clean, another causal expert. And he told me that, causal inference is much like detective work. You're trying to rule out things, one by one. Do you agree to this particular statement? How do you feel about it?
Oh, of course. You're always trying to rule out other alternative explanations. It's actually I learned a lot from Dr. Nick Huntington-Klein. I have his book. He's actually answered questions for me. I've just randomly emailed him questions. He probably doesn't remember, but I actually learned a lot from him. So actually being on the podcast, following up to him makes me very nervous because I learned so much from him. So if he's watching, again, that's why if I am nervous, it's because I saw you had him on the podcast. I'm like, I don't know how you can follow up to someone because he makes statistics like almost like easy as making ice. That's how I describe it, especially when you read his book. But yeah, you're ruling out alternative explanations. What other factors might have, so in our case, right, when we roll out a large scale foot patrol initiative and we're not rolling it out everywhere, what other factors could have explained this decline in crime other than just having this large scale, surplus of patrol strength on visible foot patrol? So it's all about ruling out other alternative explanations to why there might be, why you might have seen a decline at all in these particular treated areas. So it's a lot like detective work, detective work in general.
Yeah. Let's talk about SCM, synthetic control methods. At least in my field of marketing, when people talk about DID, in the same breath, they also talk about SCM as though it was some alter ego of DID. In my field, marketing, people can get away with assuming that, a particular city or a geography is kind of similar, and you can somehow lump them together and assume that, they're going to behave differently. But I'm pretty sure that cannot be done, in a very sensitive domain like policing. I just saw a remark on LinkedIn where I think a person from epidemiology, he said that, hey, you know what? If somebody is going to prescribe me a cancer medication, saying that it has been done via SCM, I'm not going to take it. So where do you stand on this? Yeah.
If it was prescribed and that person
said I know it was
prescribed by SEM.
No, if a medication is born out of, a methodology like SEM, of course, people don't do it, but I think it was hypothetical. People generally take the RCT route for medications. I know that, but I think he was making a point that SCMs are perhaps not that reliable, given that, you're trying to lump up a lot of, let's say, control geographies, which may not be true at all, or control units, so as to speak.
I mean, that's an interesting perspective. I just think with, in policing, it's often we're going to want to have similar. So if you're experimenting with a foot patrol initiative or, in a certain group of treated areas, and we want to create like a synthetic twin for you over time, we're going to want to ensure that those your crime trajectories, right, are very similar as we approach the intervention. You're going to need a lot of pre-treatment data. And also you probably need a big donor pool, pool of untreated areas. So I think it works fairly well in most policing applications. It's often nice when we have a treatment where the timing of it is very uniform. It begins on this particular date at this particular time, and we can track, this synthetic twin to the treated area over time. And what's great about it is, I think you could just check these trends, though. That's sort of what makes it a little bit powerful. It's very easy to check if you've got a good synthetic twin. So so when we were looking at foot patrols in New York and this kind of like experimentation with it over and over again, I use, we could discuss a little later, a fairly new package called Panel Match in R. It allows you to do propensity score weighting methods, kind of in conjunction with difference and differences. And what's really great about it is it does allow for this back and forth switching of treatment.
Mm-hmm.
So in other words, you can be treated, you can exit treatment. And then when you begin treatment again, it allows you to go back in time and find a similar group of controls, right? So it allows you to reweight all of the observations, right? And then we can sort of compute the difference and differences estimator at each of these time points when there's a treatment. So it creates match sets, right? It's estimated at the match set level. So it's sort of doing synthetic control methods like that, but it allows you to start and stop treatment at any particular point in time. Mm-hmm. One other thing I kind of wanted to discuss, especially because you use that analogy with some sort of pharmaceutical literature, is another thing in policing, like these policies that we implement, they're not always permanent. So if we implement a policy and it's in effect for, let's say, a few years, I've had discussions with academics about, well, let's say we have a standard treatment variable that we're going to allow to switch on when a policy begins. Well, are we assuming that policy affects our outcome? Let's say if it's a crime outcome forever? That's not a very reasonable assumption to make. So oftentimes, if we deploy extra police officers to a fixed geography, we would expect that to influence crime in that geography almost immediate. Most research in criminology would expect that there to be this effect that happens almost instantaneously within the first few weeks. But then if we keep officers at a fixed geographic location just for 6 months, there can be a point in time where we can allow that variable to switch off. We can say, well, the effect of that police officer in that fixed geography no longer has an effect on crime. It almost becomes like the new status quo. I use an example from sometimes when I was trying to teach this to almost like a college freshman. They're like, well, shouldn't it reflect reality? I said, well, think about if you were taking a pill, right? If you were experiencing pain and I gave you Tylenol, you take the pill and all of a sudden you start to feel better. But after 6 to 8 hours, that sort of intervention no longer has an effect. You have to take a new dose of the actual medication. So it's the same kind of thing here, is that when we deploy to a particular area and it's for an extended period of time, it's unreasonable to assume that it continuously has the same effect on the outcome as we proceed across time for months and months and months. So we can almost allow that treatment variable to switch off, mm-hmm. if that makes sense. Because again, it's not always, even though it could be permanent, we won't assume that particular type of enforcement strategy will just always affect the outcome in the same way.
Yeah, you make a very good point about the treatment duration. For example, in policing, of course, there has to be ample headway required for the policy changes to get changed in the future, for it to be revised, so as to speak. But in cases of, let's say, epidemiology, the medicine has to work once it is, cleared, right? It has to work in perpetuity. It cannot just work for the first few weeks and then not work for the rest of it, right?
Yeah.
That's a very interesting point that you make. So let's play a quick game just to summarize all the insights that you shared. This is about the assumptions surrounding causal methods. Let me quickly share my screen once. Yeah, so the game is called Rate the Causal Assumptions Game. I hope you can see my screen.
Let's see. I can see it. Yep.
Yeah. So I'm going to ask you to, rate the reasonableness of assumptions surrounding these causal inference methods. Let's go with, DID's parallel trends assumptions. Do you think it is reasonable, unreasonable, or impossible?
So we're speaking specifically about DID parallel trends, right?
Yeah, maybe the
Yeah.
context could be in your domain, policing and law enforcement. You can, have that as a, yeah.
It is parallel trends are not always, well, so in the absence of treatment, we're assuming that both groups would have trended similarly.
Mhm.
I would say it's hard to say because I'm saying it's reasonable if checked, but very unreasonable if ignored. So it's in the
In between.
we'll go with between. We'll can
Okay.
we put it right in the
Yeah. It's right in between. Yeah. Yeah. Moving on, I think we just talked about SEM, but what about SEM synthetic twin assumption? How reasonable is it, or unreasonable, or impossible?
I mean, building that again, we did discuss it, sort of building that synthetic twin. I would say reasonable in most cases, but can be very fragile. So let's move it. Can we move it? Imagine where you have difference and differences. If we slid it to the right, I'm sorry, to the left,
Yeah, somewhere,
25%. Yeah.
just
So yeah,
jutting it out. Yeah. Okay.
reasonable in most cases, but it's fragile, right? But what's great about it is you can check it, and you can check the reasonableness of how those crime, those trajectories are moving over time.
Mhm. Uh, what about Satwa, the stable unit treatment value assumption? Of course, there are going to be, spillovers, in our domain and, in yours, I believe, a same set of treatment. While you're administering it to a particular county, people may get displaced and move to another county, right? So how reasonable, unreasonable, or impossible?
Well, it's very unreasonable.
Hmm.
People will, it's unreasonable, but it's
Hmm.
something you have to, I would put it in the, I would just put it as it, unreasonable to,
Okay.
actually, you know what? I
Impossible.
would just put it as unreasonable. I mean, if you
Okay.
put extra officers into a jurisdictions or on the border with a treated jurisdiction, I mean, it's reasonable to assume that they would, that
Hmm.
crime, would be displaced into a neighboring jurisdiction. But there's ways to deal with that. And one of the things I did in the Foot Patrol initiative was especially when you're looking to do, um, kind of like a robustness check, is we would take those particular treated areas and all the areas that had like a traversable border, we would
Hmm.
drop those from the analysis and we would sort of re-estimate our model. Because yeah, again, that idea of spillovers, it happens all the time. Crime and deterrence. Crime could also spill over, but we could also experience the deterrent effect. Deterrent effects can spill over as well. I
Hmm.
mean, I had some commanders when they were experimenting with a foot patrol initiative in one jurisdiction. He would put officers on foot, but he would have a car there and he would have those the turret lights on. He would basically have the police lights on,
Hmm.
so he could, there could be this general deterrent effect that he wanted to spill over into the neighboring jurisdiction, just to kind of help out that jurisdiction. We didn't get a chance to sort of quantify exactly how much of that was actually driving crime down, but in essence, it's unreasonable, but it's something that you just have to, in quasi experimental research and policing, you're going to have to deal with it. I don't think you could
Hmm.
just get away with it. It's not a hand waving exercise. So I would just keep it at unreasonable.
Understood. What about the sharp cutoff rule of, regression discontinuity design? Have you heard about it?
It's,
Worked with it?
of course, yeah, of
Yeah.
course I have. Its usage, I would say I haven't seen any new and sort of novel research in that area. But again, it involves a sharp cutoff, and and even outside of policing, imagine like a school lunch program where we're going to assign students to, part of the program if their household income falls, just below the poverty line. And so the other student, right? So imagine you have other students who, if their household income is just above that cutoff, they can serve as a viable sort of control group. So it's right up there at the cusps. Where I would put it. I want to be let me think about this one. It's reasonable if you have the cutoffs, right? So if the rules are strictly enforced, it's very reasonable. And if they're not, it's almost impossible. So I would put it in the reasonableness, kind of almost in between synthetic control methods and DID's parallel trend. Yeah.
Something like this. Yeah. Okay.
But again, I'm like to be very clear. So reasonable if strictly enforced, and impossible if they're not, if you're not enforcing those cutoffs. So I actually like this game because, I mean, if you it would change if we, changed, I guess, the parameters a little bit, but yeah, I like this. It's fun.
Yeah, this game does not have a sharp cutoff.
Yeah.
Yeah.
Was there something else we missed? Were we supposed to do? Oh, I see. Okay.
The perfect balancing in propensity score.
I'm going to move this over. Hold on. Are we talking about, there was another one, right? So is that one balancing?
Yeah, perfect balancing in propensity score matching. This is the last one. Yeah. Where would you put it?
I'm trying to predict, using a regression-based approach to predict you're predicting your probability of treatment. I would put it in a little bit to the left of the sattva. So like reasonable. Yeah.
Somewhere here?
Yeah.
Okay.
I mean, it's it's reasonable for the most part. Yeah, right there. Yeah, right there. About right there. Yep.
Great.
Again, something you can the balancing, with a package like Panel Match, they have really great diagnostic plots where you can use propensity score weighting methods. You can use propensity score matching. So at the time of a particular treatment, you can go back in time and you can try to achieve balance across, and you can actually use previous crime outcomes in the balancing, when you're trying to create this balance between units. But you can also use other variables that you have. So if you can check it, it's pretty reasonable, but most of the time not, propensity score matching methods, not so much. So I think it looks perfect right where it is. I mean, some are going to disagree.
Yeah, that's okay. Everybody's entitled to their opinions, and
I have to go back and see what Dr. Huntington Klein did, because
I would say,
did he agree with this?
Yeah, more or less, you guys are on the same page, I would say. Yeah, this was wonderful, Thomas. I'll just stop sharing my screen, and we'll move to the last few questions.
Sure.
You talked about a particular package known as Panel Match that you use to analyze CompStat data. Is it an R package or a Python package? Can you detail it up?
Actually, currently it's an R package. I don't know if the authors of the package have extended it to have functionality in Python, but it's strictly an R package. I think it's a great package because it can generalize to almost any treatment pattern. So you can have staggered entry. Units can begin in the treatment condition. It can estimate the ATT. It can even estimate an ART, so an average treatment effect of a policy reversal. Okay. That gets a little bit confusing because you do need units that stay in the treatment condition. And then so essentially units stay in the treatment, and then you compare those to the units that switch out of treatment. The reason I asked that question to you a little while ago, because if every unit starts and stops at the same time, then treatment is deterministic and you can't estimate the ART or the reversal. So it's a great package. It can generalize to almost any treatment pattern you have. It can handle on and off treatments. So it allows you at the time of treatment to then go back, and actually it's defined by the actual user. So if you're using the package, so take for instance a foot patrol initiative, ones that I've evaluated, or actually no, you use the CompStat example. So when CompStat is called, there's 77 patrol jurisdictions. They're typically going to call one particular county, because New York City is made up of 5 counties, right? So they're going to call, let's say, a county to the meeting, but they're only going to focus on a small number of actual jurisdictions during the meeting. They're going to pick, so let's say we have 10 precincts coming to the meeting. The commanders show up with their crime analysis, some of their crime analysis staff, and they have to defend what's going on in the precinct. So what we did is we treated the CompStat meetings themselves as their own type of treatment. And part of that was, to tell you how I did it, was just over the last several years, I was writing down the dates of the meeting and who was presenting. There is currently no data set on CompStat meetings in New York. So I wrote down the dates of the meetings. I wrote down who presented. I wrote down who, we essentially have data on who presented at CompStat, which commanders got questions just from the seat, and who didn't present. So what's great about this package, again, remember I said parallel trends aren't so parallel. What you're able to do with this is at the time a particular precinct is treated, if you're getting called to a CompStat meeting, and again, I'll get some pushback from this, it's probably because you're not performing particularly well. And by performing, I mean your crime number, you're probably experiencing some crime spike. And so, parallel trends, when we tried to assess them, again, are not entirely perfect, right? So to compare that jurisdiction to all, when we try to look at parallel trends, it was kind of messy. What the package allows you to do is you can adjust for those previous crime outcomes, right? And you're almost imposing conditional parallel trends. So we can find jurisdictions, because there's 77 of them. And if only 3 are presenting, we can find a subset of jurisdictions that were kind of looked like you, could have received CompStat, could have been called to present at the meeting, but did not. And we're going to reweight those observations. We're going to give you more weight in the analysis. And what's great is the package allows you to go back in time as far as you'd like. So for us, when they call you to CompStat, they're likely to be looking at your 28-day and 56-day crime patterns, so for us, if we're looking at a monthly time frequency of crime for these jurisdictions over time, well, we might want to go back in time, 28 days, 56 days. We could even go back 4 months and try to find a jurisdiction that looked like you as we were approaching CompStat. So it's sort of like a synthetic control, and we're going to reweight observations accordingly. So panel match is great. And then, of course, it allows you also to select how far forward you want to go to look for policy effects. So if CompStat is really moving the needle on crime, well, we can see, okay, 1 month after CompStat, 2 months after CompStat, 3 months after CompStat, how do you compare to the jurisdictions that didn't get called? We did this at the monthly level. We did this at the weekly level. We're also experimenting, looking at this at the daily level.
Interesting.
Again, we're just assessing how police managers respond to these CompStat meetings. Do they become better crime fighters locally within their commands after these meetings? And I'm really looking forward to it. I mean, I'm still working on it. So I imagine by the end of this year, I'll have some of the data, have it all sort of ironed out. So the data is actually still coming in, because we're actually going to we're actually assessing it throughout 2025. So I'd like the actual year to end before I put out the results. But panel match is great. There are also other ones. So as you can see, I'm very interested in these kind of treatment patterns where there's this switching back and forth, because it's just, I feel you see this very often in real world policing applications.
Yeah, very interesting package. I'm going to definitely check it out, and perhaps it can be of greater use to my field, marketing, as well. Moving on to our last question, Thomas. what resources would you suggest to someone, looking to get started with causal inference? What has been your go-to resources?
Oh, well, obviously, I actually have it somewhere behind me. I would use Nick Huntington Klein's The Effect. It's a very good book. Again, he makes learning econometrics. It's again, I describe it like making ice. Scott Cunningham's Causal Inference.
Yeah.
The mixed, is very good. I would say starting with those. Those would be probably my two top recommendations. And what's good about The Effect is, he has a ton of examples in both R and Python. Yeah. So as you're moving throughout that text, you just have so many different applications that you can apply it to. So I would he has the second edition out. I only have his first edition. So I think you discussed a little bit about some changes or amendments to the second edition.
Yeah, the second edition is available online. It's not a hard print yet, but I think, it's of course available in hard print, but yeah, it's freely available as a, website here.
Yeah, I definitely have to get my hands on that as well. But those are the two. I mean, there's probably others, but I would say start there. See how you do. Yeah.
Yeah, and I'm also going to recommend people to check out your cross-validated answers. Those are some of the brilliant answers I have seen on DID and fixed effects, etc.
I guess you could say that public-facing profile I have on cross-validated. I don't even know how I got started. I think the best advice I would give to anyone is ask yourself, get your hands on some messy data and just start applying, start trying to use these methods. Because that's really how it all started for me. When I saw that my department was actively experimenting with foot patrol initiatives all over the city, I said, okay, well, the crime data is publicly available. All I have to know is where the officers are going. And then it just went from there. I just spent years trying to tease out causal effects. And then before you know it, I realized people were asking the same questions on cross-validated. So I just started answering them. And then, years went by, and I guess, I guess I was one of the top contributors, but I learned so much from other people, and again, like with Nick Huntington Klein, he's just great. I mean, I asked him a question once specifically about differences with different treated areas. And some of them were treated, I guess you could say, we not only had a staggered exposure, but certain groups of jurisdictions were treated with a greater intensity than others. So it was like a discrete treatment intensity. You were treated very strongly, you were treated, and I sent him my code. I asked him a question, how can I interpret all these coefficients? And he responded like right away with how to interpret it. And, he's a great resource. And so I would say just get your hands on some messy data, start asking your own questions, analyze it, and then that's really how you start to build. Because I wouldn't have got to the CompStat analysis had I not started with that initial foot patrol initiative. So everything just kind of expands. But I'll be seeing how your package applies in my case.
Yeah.
Because we do have these very sharp start and stop times. And if I may ask a question, I see that you can I saw some of the visualizations. Are you able to just like select out slices of time and it can estimate a treatment effect for you by how you define it?
Yeah. So we have this window feature where we kind of, specify whether that particular window period had a, treatment or not. And the algorithm will tell you whether there was a causal effect or not for that particular window. And you can create many such windows, each kind of depicting a different treatment or the same treatment. But in our upcoming version 2, we are going to build in the staggered events DID as well. So it's going to be exciting.
I think that's great that, you could slide, you could just kind of pick that out.
Yeah.
That sliding sort of window. I can't wait. I mean, I think for crime analysts here, like I said, I work on the ground. I'm going to be sharing it with them and we'll see what we could do because we often experiment with things at very structured slices of time. So I really can't wait to start using it in my day-to-day. So sure. I just want to say thank you for that.
Yeah, I'll be happy to, extend a free trial to you, and I'll be happy to, get a lot of feedback from you so that we can improve the product further. I think that will be great. But going back to your recommendation, it's very interesting. You made the point that, handle messy data. I think where a lot of college graduates, struggle is that they have been habituated to dealing with really pristine data, right? And when they come to the real world, they say that, oh, the data is so messy, and I'm applying, let's say, linear regression or DID, and things are not panning out the way I anticipated. But it's a really great advice from you that, start practicing with messy data, and that's how you get good at it. Yeah.
That's definitely how you get good at it. I mean, I when you have to pull the crime data and then link it or merge it with the precinct staffing data, and then you have to get data from, you have to get census data, and then you have to merge all these data sets, then clean them. And it's, you start to get very good at it. But I think the mistake a lot of, I guess, college professors do is they give you sort of the canned data sets that are in the packages that are already cleaned for you.
Yeah.
And then they say, yeah, just test it out on this. But really the skill is in finding your own messy data, and you just have to get started. And that's actually ties back into what I said initially, is I wanted to ask my own questions, and I wanted to analyze I wanted to do my own research instead of being told what to do and what to believe. I think that's really the beauty of causal inference in general, is when you get good at these methods, you can start answering your own questions and start thinking more for yourself. And I think that's made me a better analyst, better cop. So,
yeah. Sergeant Thomas, this was really wonderful. Thanks for your time. And, this was really a learning experience for me, how causal inference is implemented in policing and law enforcement. Really, thanks for your time. This was really illuminating.
Thank you. Maybe we can do it again in the future.
Definitely. I'm going to call you again and pick your brains on, DID and other, advanced causal methods. Thanks for your time. Take care.
Thank you so much. Yep.